In this video, we're going to look at how to measure and calculate molar quantities of gases. We don't often use masses to measure the quantity of gases simply because it's difficult to physically measure the mass of any gas because the gas always occupies the full space of the room that they're in. Instead, we can use a ratio that we call molar volume in order to quantify gases. Molar volume is a measurement of how many liters of space a gas occupies per mole of gas that we have. We use this measurement because at a specific combination of temperature and pressure, which is what we call standard temperature and pressure, we have determined a relatively specific measurement of the exact volume that gas occupies. Standard temperature and pressure is 0 degrees Celsius, which we use the Kelvin scale for, so 273 degrees Kelvin, and atmospheric pressure, which we can shorten to 1 atmosphere, which using the standard measurement for pressure of kilopascals corresponds to 101.3 kPa. These measurements are not useful right now, but when we learn to calculate gas volume in more detail, they will come up again. What scientists have determined is that at 0 degrees Celsius and atmospheric pressure, 1 mole of any gas has an approximate volume of 22.4 liters per 1 mole of gas. Now, using this information, assuming that we're dealing with standard temperature and pressure conditions, we can use this in order to calculate the amount of mass or even the amount of particles of gas. For example, if we know that this balloon here is filled with helium gas and has a volume of 875 milliliters, we can calculate the mass of this gas without any of the problems of actually trying to weigh this balloon. So, we know that one of our conversion factors is going to be 22.4 liters per 1 mole of gas, but we see that we have a problem with this unit. It's in milliliters, not in liters, but that's a quick conversion that we can fix relatively easily. We know that 1 liter is equal to 1,000 milliliters. Milliliters is in the numerator and the denominator, so we see that they cancel, and now our measurement of helium is in liters. Now, if we wanted to find out what the mass of this gas is, the first thing we need to do is convert liters into moles. So if we want to cancel liters, and we know that at standard temperature and pressure, 1 mole of gas is equal to 22.4 liters, we can put liters in the denominator and see that they cancel, and this calculation would tell us the amount of moles of helium gas that we need. But since the question asked for mass, we have another unit conversion to do. Now, we need to find out how many moles, or how many grams rather, 1 mole of helium gas weighs. So let's go to our periodic table and find that helium has a molar mass of 4.00 grams per mole. So if we put that in, we can see that moles cancel, which leaves us, if we've canceled all of our units correctly, with grams of helium. If you put this into your calculator, you will find that this comes to approximately 0.156 grams of helium gas, rounded to 3 significant digits, because that's how many our initial measurement showed. If we move to the next example, we can see that we can use the opposite process in order to go from grams in order to calculate the volume. So here, let's say that we actually, rather rarely, know the mass of a specific gas, a common pollutant that is common as an industrial byproduct, nitrogen dioxide, and we want to find out what the volume of this gas would be at standard temperature and pressure. So here, if we want to convert grams into liters, we can't do that directly, but we can convert grams into moles first. So if we want to cancel grams, we need to put 1 mole in the numerator and have grams cancel out by putting it in the denominator. If we go to our periodic table to look up molar masses, molar mass of oxygen is 16, molar mass of nitrogen is 14.01. So 14.01 grams per mole. And then we need 16 times 2 because we have 2 oxygen here. 16 times 2 is 32. And if we do some quick arithmetic here, we've calculated that the molar mass of nitrogen dioxide is 46.01 grams per mole. If we do this, this tells us the number of moles of nitrogen dioxide, but since the question asked for volume at standard temperature and pressure, we need one more unit conversion, and we know that 1 mole of every gas is 22.4 liters at standard temperature and pressure. We see that moles cancel, and we are left with liters of nitrogen dioxide. If you put this into your calculator, you can find that this comes out to approximately 22.2 liters of nitrogen dioxide. Again, 3 significant digits because that's what our initial measurement showed. If we try this seemingly complicated question here, we see that if we mix up volume of liquids with volumes of gases, we can see that this question, you have to be careful with your units. So it's very important to write out the chemical that we're measuring and keep in mind the state of matter as well. So in this situation, we start with 175 milliliters of liquid water. I'm writing that state of matter here just to be safe. Initially occurs at 25 degrees Celsius, but then we're going to boil it into water vapor so that it is a gas. And if we keep it in the gas form at STP, what is the volume of this water going to be at standard temperature and pressure? So this is weird because we have the volume of the liquid as our initial measurement, but we're looking for the volume of the gas as our final measurement here. So we can't do much with the volume of liquid. We eventually need to find out how many moles this is going to be to find the gas volume. But because this is given as a volume and not as a mass, we need to use water's density. So from the question, we are given that 1 milliliter of water is equal to 0.997 grams, so milliliters cancel, and this tells us the approximate mass of the 175 milliliters of water. From previous questions we've done, we know that the molar mass of water is 18.02 grams per 1 mole, and we set up this molar mass conversion here so that grams is in the numerator and the denominator, so they cancel, and now that tells us the amount of moles of water that we have within this situation. Now, if this water is evaporated and then kept in gas form at standard temperature and pressure, we can figure out the volume because we know how many moles of water we have here. We know that at standard temperature and pressure, 1 mole of every gas is 22.4 liters. So that tells us the amount of liters of water we would have after it evaporates and after it gets kept at standard temperature and pressure. If you put all of this into your calculator, you will get that this comes to a rather large 216 liters of water. And again, this is in the gas form. Take note, 3 significant digits, just like our initial measurement. Although this is fairly simple because we can only do these calculations in one condition, it is still useful to be able to interconvert between volume of a gas and mass as well. And in subsequent units, we'll be able to do gas calculations at more than just standard temperature and pressure.